Let's review how to add and subtract rational numbers. Before getting started, let's go ahead and define what a rational number is. So when we say rational number, what we mean is a number that can be written in fraction form. So a number that can be written in fraction form. So if, let's say we have, let's look at some examples. Let's say we have 1.4. Okay, that's a rational number because we can write it in fraction form. We could write it as 1 and 4 tenths and then simplify it to 1 and 2 fifths. Okay. Another example of a rational number, well, just if you have a fraction, 1/2, that's already in fraction form. 2.6, another example, okay? In this case, we can write it as a mixed number, which that's in fraction form, so 2 and 6 tenths. Or if we want to go ahead and reduce that, it would be 2 and 3 fifths. So all of these are rational numbers. Okay, so irrational numbers are the opposite. They're numbers that we are unable to write in fraction form. So take a minute and think about maybe some irrational numbers. All right, so if you've had a moment to think about it, some irrational numbers would mainly be like imperfect squares. So let's say we have like the square root of 2. That is if you evaluate that, the decimal continues on and on infinitely. The square root of 3, that's another irrational number. But the square root of 4 is a rational number because we can take the square root of 4 and get 2, and 2 can be written as a fraction, 2 over 1. So here's a couple of examples of irrational numbers. Pi would be another example. That decimal continues on and on infinitely, and consequently we're not able to write it in fraction form. So let's look at adding and subtracting some rational numbers now. Fractions tend to be the more challenging piece to this, so we're going to focus on looking at fractions. Let's say we have 3 fifths plus 1 fifth. Okay, so what we want to first look at is the denominator. Okay, if the denominators are the same, we do not have to do anything to them. We can just add our numerators. So in this case, our denominators are the same, so we can just bring over that common denominator. Okay, and then we just add our numerators. 3 plus 1 is 4, and then we just want to check and reduce it if needed. 4 fifths is in simplest form. So we're good there. Same with subtraction. If the denominator is the same, we just need to move that over. So let's say we have 7/16 minus 1/16. Okay, again, those denominators are the same. They're both 16. And we just subtract our numerator. 7 minus 1 is 6. Okay, go ahead and reduce that. Okay, so when we reduce fractions, we have to think of a number to divide both the numerator and denominator by. So we could think of the greatest common factor, or if you're struggling with that, you could just, if they're both divisible by 2, go ahead and divide them by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. All right, 3/8. There's nothing that we can divide 8 and 3 into, so we're going to leave it in simplest form there. So let's look at adding and subtracting fractions with different denominators now. Let's say we have 1/2 plus 2/3. So let's go ahead and use the LCD method, and that is just the least common denominator. So we're looking for the smallest common denominator in both of these fractions. So we're going to go ahead and rewrite these fractions and come up with a least common denominator. Okay, so we just need to think of the multiples of 2 and 3 and figure out the one that is common. So if we do 2, 4, 6, I'll stop there. And then we do the multiples of 3, 3, 6. You can see that 6 is our least common denominator. All right, now we need to work out our numerators. We multiplied 2 by 3 to get to 6, so we have to do the same thing with that numerator. 1 times 3 is 3. All right, and then also the second fraction, we have 2/3 has been changed to denominator of 6. That was multiplied by 2, so we have to multiply that numerator by 2 as well. All right, so from here we can just add our numerators together. 3 plus 4 is 7. And here we have an improper fraction. The numerator is larger than the denominator. So we can go ahead and change that to a mixed number. Okay, so a mixed number has a whole part and a fraction part. So we're taking a whole 6 out of there, and then we have a remainder of 1, and we just bring over that same denominator. All right, so that's how we're doing that. So 1 and 1/6 is our sum. Let's go ahead and look at a different one now. Let's subtract this time. So we have 3/8 minus 1/3. Again, we'll use the least common denominator method. So we're going to go ahead and rewrite each of those fractions. Okay, so looking at 8 and 3, the least common denominator for those two numbers is going to be 24. All right, 8 times 3 and 3 times 8. So we'll go ahead and multiply that numerator by 3, and we have 9/24 minus 8/24. Subtract the numerators, and you're left with 1/24 as the difference. All right, let's look at another way of doing this. This is actually somehow this is still here. I'll clear that off. Okay. So here we have 4/5 plus 7/10. Now, another way that if you're having trouble with finding the LCD is you can take the denominator of the first fraction and multiply it by the second fraction, and vice versa. Take this 10 and multiply it by the 4/5. So let's go ahead and do that right now. I'm going to use some different colors just to help us see what we're doing. So we're going to take this denominator here, this 5, and we're going to multiply it by the second fraction. So we multiply the numerators and the denominators by the same number. That's how our fractions stay equivalent. Okay, if we multiply the denominator by 5 and we multiply the numerator by something else, it's not, that fraction would not equal 7/10. So we're maintaining equivalent fractions. Okay, when you do this, your numbers will get a little bit larger, but that's okay. Just may have to reduce a little bit more. So 7 times 5 is 35 over 50. And let's go ahead and take the second fraction's denominator and multiply that by the first fraction. We're going to take this 10 and multiply it by the 4/5. So 40 over 50. And you can see that both of these denominators are the same. So we can go ahead and add. So 40 plus 35, 75 over 50. And then we can go ahead and reduce this. If you were to write it as a mixed number, we would be writing it as 1 and 25/50ths. And then we could just reduce it to 1 and 1/2. So let's look at the same problem using the LCD method so you can kind of see what the difference is between the two. So we're doing 4/5 plus 7/10. If we were to do the LCD, we could list the multiples of 5 and 10, and we would find that 10 is our LCD. So the LCD is 10, least common denominator. All right, that fraction stays unchanged because it's already at 10, and we had to multiply 5. We had to take 2 5s to get to 10, so we want to do the same thing to the 4. So we have 8/10, and then if we add 8 and 7, we get 15/10, and then we change it to 1 and 5/10. That's our mixed number, and then reduce it to 1 and 1/2. So really the difference just lies in, you can see that when you get this piece here, that the numbers are larger. So if you don't like working with larger numbers, you may want to stick with this LCD method. However, if the LCD method is confusing and you have trouble with it, then this is a no-fail way of doing it as long as you're multiplying correctly. All right, well, that is our lesson on adding and subtracting rational numbers. Remember, when you add and subtract fractions, it's the same process. We're just finding common denominators, and then from there, moving on to adding and subtracting numerators. Oh, and I'll just do one more subtraction, actually. Sorry about that. Let's look at one more here where we're subtracting fractions using that multiplying the other denominator method that might work better for you. So let's say we have 5/6 minus 1/2. And we want to go ahead and do that multiplying by the other number. So we're going to take the denominator of 5/6 and multiply that by this fraction here, and we're going to get 6/12. Okay, and then go ahead and do the same thing over here. We're going to take the 2 and multiply that by 5 6. And we're going to have 10 12s. All right, common denominators. Now we just want to go ahead and do our subtraction. 10 minus 6 is 4 12ths. Okay, this fraction can be reduced. The GCF of 4 and 12 is 4, so we divide both by 4 and we get 1/3. All right, well, thank you for watching. Go ahead and give the self-assessment a try, and then once you're comfortable with those problems, feel free to try the quiz in this week's lesson as well. Have a great day.